In this video, I introduce basic distance concepts in machine learning. Machine learning methods often require measuring the distance of two vectors or arrays with the same dimensions. Euclidean distance measures the straight-line distance of two vectors, namely, the Euclidean distance is defined as the length of a straight line connected from a vector x2 to vector x1. For a neural network model, its output is x hat 1 to x hat 5, and the corresponding ground truth is y1 to y5. A Euclidean distance can be used to evaluate loss of the predicted value from the true value. Given two vectors x1 and x2, cosine similarity measures the angle theta between two vectors x1 and x2 by the inner product of x1 and x2 that is normalized by the two norms of x1 and x2. Cosine distance is defined as 1 minus cosine theta. Cosine distance is not a true distance, and instead is a normalized value. Dot product is defined as the inner product of two vectors x1 and x2. All three metrics are used to measure the similarity between two vectors. Dot product is a scalar value smaller than values of vector x1 and vector x2. And the cosine distance and the similarity range between -1 to +1. Kullback-Leibler divergence is the statistical distance between one probability distribution P from a reference probability distribution Q. P and Q in KL-divergence is not commutative. KL-divergence is defined as sum over discrete x or integral over continuous x, where lower p and q are probability density functions, and capital P and Q are probability mass functions. For example, P has a distribution over x, and Q has a distribution over the same x. And then using the definition of KL-divergence, we can calculate its value by sum of three terms. We get the KL-divergence value is 0.085296 knots. If P has the same distribution as a reference Q, KL-divergence is 0. If P has a different distribution, for example, 0.8 at 0, 0.1 at 1 and 2, we use the same formulation to calculate KL-divergence. Its value is 0.460 knots. Namely, this distribution is closer to the reference distribution than this P, because this distribution has a smaller divergence from a reference distribution Q. For more details, please check with these references. Thank you. Bye.